one of the earlier writers that was addressing the Gulf of Maine referred to it as a most peculiar body of water. And what I'd like to do today is share with you some of the reasons why that was this consideration. So with that, hang on. Okay, the Gulf of Maine. The Gulf of Maine itself is distinct from the Atlantic Ocean in terms of geology, its age, its water characteristics, and the productivity. The coast of the Gulf of Maine itself, which starts here at Cape Cod and goes all the way around to Cape Breton, Nova Scotia, is about 7,000 miles long. The Gulf itself is a rectangular depression, and it consumes about 36,000 square miles. The average depth in the Gulf of Maine is 490 feet. And the Gulf of Maine also has the world's highest tidal variations. The Gulf of Maine has been described as a sea within a sea. And as I mentioned earlier, it goes from Cape Cod to Cape Sable, Nova Scotia. There's as much area in the Gulf of Maine in water as there is in Maine on land. Predominantly, the Gulf has rocky shores. There are hundreds of harbors and thousands of islands. There are well over 3,000 species of that live in the Gulf, and those include microscopic plants and animals to fish, to birds, to whales. And there are 52 species of fish or shellfish that are commercially harvested from the Gulf. The edges of the Gulf of Maine are largely unpopulated. The only large population centers are Boston, Portland, and St. John's, New Brunswick. This is the border, the Canadian-U.S. border that goes up through the Gulf of Maine. This was starting out. I'm going to start out with looking at a few of the areas and a few of the shoreline type of what's on the shoreline for the first few slides, and then move on into some more specifics. This is Digby, Nova Scotia. It's on the eastern side of Nova Scotia, and it's probably one of the first notable harbors as you come up the coast from Nova Scotia. This is another picture from Digby, and it is showing what the rocky shores that tend to dominate the Gulf. As you move up towards the top of the Bay of Fundy, there are Hopewell Rocks. And Hopewell Rocks have been basically advertised as the place where you can go and walk on the bottom of the ocean. And there are sirens that will sound when this tide is starting to come in, so that people will get off the beach or off the seabed. And to give you an idea of the size of these rocks, there's an individual standing there for perspective. Come down the coast a little further, and this is opposite Deer Isle and Stonington. On Deer Isle is Isle de Haut. And what's notable about the Isle de Haut is that it's the location of what's likely the second largest supervolcano eruption in the world's history. And not to worry, that was about 430 million years ago. So we're all safe from any volcanic activity. Isle de Haut itself has volcanic rock between magma and tuff of 3 miles thick. Moving down the coast a little bit further is the Scudic Peninsula. The Scudic Peninsula is part of Acadian National Park, and if you look over to these hills in the background, that's Mount Desert. Schoodic is opposite Bar Harbor, across from Frenchman's Bay. I included this because I think it's a very impressive picture from the Schoodic Peninsula itself, and that this is a basalt dike, and there are basalt dikes, you know, throughout the state, but this is probably one of the best examples of one. And if you pay attention to it here and you look at the edges, you can see that the basalt is actually worn down lower than the adjacent granite. Moving down, predominantly when you get to the Mount Desert Island area, granite predominates the shore. Most of the Gulf of Maine itself is a metamorphic rock in origin, as in this picture of Portland headlight. Moving down, when you get towards the more southern parts of Maine, from Portland down to Kittery, the coast is comprised of rocky headlands with pocket beaches between them. As I said earlier, the coast is largely rocky. Over the past 2 million years, there have been 4 to 5 glacial periods. And by a glacial period, it's just it was an ice age that took place. The Gulf of Maine itself was formed by the Laurentide Glacier, which is the continental glacier, that covered parts of North America. And that was between 85 and 16,500 years ago. Much of the sediment in the Gulf of Maine is from that last ice age, and the seabed itself has areas where the sediment is up to 260 feet thick. Going down to the other edge of the Gulf of Maine, you get to Cape Cod, and it's noteworthy because, again, this was formed by the glaciers, and it's a glacial moraine. And a moraine occurs when a glacier is flowing as fast as it's melting. So it basically stands in one spot and acts like a conveyor belt, dumping material onto the ground. The Gulf of Maine itself, I said earlier, has better than 3,000 birds and marine species, and there's far more diversity in the Gulf of Maine than south of Cape Cod. And some of the reasons for that is because of higher water temperatures and salinity to the south. The seawater and characteristics in the Gulf can vary by temperature, salinity, density, and nutrient content. The seawater itself dissolves, seawater contains dissolved salts, minerals, and gases. Dissolved salts make the water more dense. Dissolved gases come from the atmosphere, from respiration of creatures living within the Gulf, from photosynthesis from algae and phytoplankton. And those gases include nitrogen, oxygen, and carbon dioxide. The nutrients nitrogen and phosphorus feed into the Gulf from detritus and from river runoff. The true marine salinity is 35 parts per thousand. The Gulf of Maine itself, on the surface, tends to average about 32 parts per thousand, and in the basins, it's slightly saltier at 33 parts per thousand. Estuaries make up about a third of the Gulf. The Gulf of Fundy and Cape Cod are the most estuarine areas in the Gulf of Maine. And it's interesting that 1/3 of the Gulf is estuarine, because if you consider the rest of the world's shorelines, less than 1% of them are estuarine. So we have a wealth of estuaries up this way. And this, speaking of wealth, is the Little River Estuary at the Wells Reserve. And this is salt marsh behind it. There are three basic coastal plant communities in the Gulf. You have salt marsh grasses, seaweed, and seagrasses. These plants grow in tidal and subtidal communities. They provide food, shelter, and nurseries for creatures living in the Gulf. They also are important because they sequester carbon. They sequester and store carbon. Seaweed itself grows intertidally and on exposed bedrocks and boulders. And one of the requirements for seaweed to grow is that it has to have a stable surface. If there's a boulder on the beach and the waves will move it around, seaweed will generally not grow on it. And this particular seaweed is fucus, a common weed in the Gulf. This is a picture of a diver at Cassius Ledge. Cassius Ledge is a national marine preserve, and it has a rich variety of sea life in it. And over to the right here, oops, excuse me. Over to the right, you can see where Cassius Ledge is located, pretty much off the coast of Portsmouth. This is another picture of a kelp mound from Cassius Ledge, which is not really all that deep. Seagrass is the second plant community I'd like to discuss today. And seagrass will grow in silty and silt and silty sand, and it will grow until the light dims and it can't photosynthesize anymore. It can be intertidal, or it can remain submerged 24 hours a day. It captures sediment and reduces turbidity. So by capturing sediment, it reduces the amount of material in the water, makes the water clearer. It also provides food and habitat. Pieces of seagrass, detritus, will break off, and creatures within the Gulf will eat them. It also makes a good place for animals and fish to hide. Seagrass itself is really important because, much like seaweed and phytoplankton, it sequesters, and it will store the carbon into the seabed. Eelgrass is the most common seagrass that occurs in the Gulf of Maine. And interestingly enough, within the last month or so, it was noted in the Portland Press Herald that the Casco Bay eelgrass meadows had a 54% decline between 2018 and 2022. It's a significant loss of seagrass, and it's still being studied, but some of the suspects in the seagrass loss are warming waters, algal blooms, reducing sunlight and photosynthesis, and green crabs, of course. Green crabs, one of the most invasive predators that seems to be on this coast, as green crabs will eat, young green crabs will eat the seagrass itself and clip it off at the base, while more mature green crabs will dig in the mud at the base of the plants and tend to uproot them. The Gulf of Maine watershed itself is 70,000 square miles, and it includes the state of Massachusetts, New Hampshire, Maine, Quebec, even though Quebec has no oceanfront property, New Brunswick, and Nova Scotia. The watershed itself empties about 250 billion gallons of fresh water into the Gulf annually. And if my calculations are correct, that would be about 375,000 Olympic-sized swimming pools worth of water flowing into the Gulf each year. The river discharge and the Scotia Current, which comes across the Nova Scotian continental plate here, reduce the salinity. And we'll talk about that a little bit later, why that happens. 4 of the largest rivers in the Gulf of Maine, the St. John River, the Penobscot River, the Kennebank River, and down here, the Merrimack River, New Hampshire. Gulf of Maine tides. Again, as I said, we have some of the highest tides in the world in the Gulf of Maine, Bay of Fundy. The Gulf of Maine tides are mixed semi-diurnal tides. That means we have 2 high tides and 2 low tides each day, and the high tides are not equal to each other, and neither are the low tides. They're different. The tides are an important part of the coastal building process. Eroded bluffs, embankments provide sand and mud for the building of mud flats and salt marshes, and also sand flats. The tidal range in the Gulf of Maine ranges is listed down below. In Wells, it ranges between 8 and 12 feet. Going up to Passamaquoddy Bay, pretty much on the Maine-Canadian border, about 28 feet. And the Bay of Fundy itself actually goes to about 52.5 feet in tide height. And that's the world's highest tides. Oops, hang on. And I guess it bears repeating that they are the highest tides. And there's a reason for that. And it is because the Bay of Fundy shoreline converges to the head of the Gulf. It becomes narrower and shallower as we get up towards the head of the Gulf. And what that does is it forces the water ever more higher in terms of the tide. There's another reason for that, is that the water within the Bay of Fundy oscillates every 12 to 13 hours. It basically resonates at the same time as the tidal cycle. So we have high tides coming in, and you have the geography of the land squeezing that water into a smaller place, but also the water in the Bay, in the Gulf of Maine, oscillates back and forth. And that oscillation goes in conjunction with the high tides. So it just adds to the tidal range. And those oscillations amplify the tidal range throughout the Gulf of Maine. In fact, you'll find that south of Cape Cod, the tides are generally significantly lower than even the Cape Cod itself. Picture of the Bay of Fundy, and I think this is one of my favorite pictures, and it reminds me of I think it was 4th grade geography, where I first saw the picture of what the tides of the Bay of Fundy did, and it really is quite impressive to see just how far these tides will drain out. Tidal mixing. Tidal currents occur with the rise and the fall of the tide. Higher tides tend to cause more mixing. A tidal current will mix the water from the top to the bottom, and it will leave no distinct water level. Both wind and currents cause mixing, and areas that have estuaries, inshore areas, and offshore banks like George's banks have the most mixing. Some of the characteristics of tidally mixed water, and we experience this in the Bay of Fundy especially. In the summer, the surface temperature of the water is cooler, and in the winter, it's warmer. What that does is it allows for a more even plankton production throughout the year. You also have gravelly bottoms because the sediment, the currents remove the fine sediment and leave rocks and boulders. Maine has greater than 2,000 islands. The the Gulf of Maine has probably around 4,000, but I have not been able to find a definitive number. So greater than 2,000 pretty much covers it. What happens with the islands is that the water circulates around the islands, causing it to become oxygenated and nutrient enriched. Excuse me. The nutrients in the water tend to be concentrated by a funnel effect, and that funnel effect of the water being squeezed by the islands itself. Refraction occurs when waves hit the shore. Now, it could be the shore of an island, or it could be the shore on the coast, and they change orientation. And when waves approach a beach or a shore, they generally change at an angle. They hit, and then that angle changes, and it tends to move sand down the coast, and it's possible to form a sandbar or a sand spit. And a sand spit, for want of more explanation, is basically a beach. I want to include this picture from the Penobscot Bay area in order to point out all the islands that are in this particular area. These islands go throughout the Gulf of Maine. And one of the interesting things, and I think that one of the reasons why the total number of islands is not definitive, is because there's no real definition that I could locate as to what constitutes the minimal size for something to be an island. So it appears that if you have a big rock sticking out of the water, that probably gets thrown into the total of the islands. One thing I wanted to make note here too, this West Passage, this is pretty much Camden area here, and this is Vinyl Haven, one of the larger islands off the coast. And this passage itself is 425 feet deep. And, it kind of shows that the depth of the Gulf of Maine can be very deep close to shore. I want to mention that the thermocline. The thermocline is a transition layer between the warmer water that's above and the colder water below. The warmer water that's above is often turbulent and mixed by the wind and currents. The colder water that's below tends to be calm. And the thermocline is made of horizontal layers, and those layers are formed by differences in temperature and saltiness of the water. They provide a thermal habitat for fish and marine creatures. Okay. The water layer temperature range preferred by different species varies. Cold-blooded species such as cod, a major fishery in the Gulf, prefer 41 to 59 degrees Fahrenheit. So it's a good spot for cold water fish. Gulf of Maine currents. The Gulf of Maine has two currents that influence it. One is the Labrador current, and the other is the Gulf Stream, and they meet at the Grand Banks. And when you look at the Gulf of Maine and even the state of Maine, the Grand Banks, Georges Banks, they were part of a very important fishery. And while they are distinctly different, the same fishermen went to the same areas. But this Labrador current enters the Gulf of Maine through the Northeast Channel. The Labrador current itself is cold, nutrient-rich, and fresher water that comes from the North Atlantic. And it's fresher because ice that has melted from Greenland puts water into the sea and reduces the salinity. The Labrador current comes along and flows across the Scotian shelf, part of the continental shelf, as the Scotian current. The Gulf Stream, on the other hand, is warm and salty. The Grand Banks here is a major fishing ground, and that's where the currents meet. The relative location of these currents changes yearly, and that's due to something called the North Atlantic Oscillation, which needs more explanation, and I can't really get into it right here. But basically, what the North Atlantic Oscillation does is it helps to power the ocean currents throughout the world. Between 1990 and 2010, the Gulf Stream itself has consistently moved north because of that North Atlantic Oscillation. Oops. Gulf of Maine currents, and there's a number of them here. So the Nova Scotia current, keep in mind this is the add-on to the Labrador current. It enters the Gulf of Maine through the Northeast Channel. Once it does, the Earth's rotation causes the water to flow up the Nova Scotian coast. And river runoff and tidal surges contribute to the Gulf of Maine currents. So the current comes in, Scotia current comes in here, makes a run around the Bay of Fundy, and it comes down as the coastal current. Over here, you'll notice is the Gulf of Maine Gaia. And there are a number of Gaias in the Gulf of Maine, but this is one of the most noteworthy ones. The water will come here and it'll start doing a counterclockwise flow. And it sets up a system of large circular ocean currents. And that circular ocean current is caused by wind patterns in the Gulf and the Earth's rotation. The Gaias themselves can and generally do cause upwellings, bringing nutrients up from the colder, deeper water. Off Casco Bay, the surface current starts flowing southeast, causing a counterclockwise current over Georges Bank. The surface water flows about 7 nautical miles daily. A complete rotation of the water within the Gulf takes about 3 months, but to actually cycle through all the deep basins takes about a year. The coastal current. The coastal current is caused by rivers. The coastal current is a tidally mixed plume. You have fresh water coming from the rivers mixing with the salt water in the Gulf. It affects the water properties, including the circulation, the mixing pattern, and the nutrients. Excess fresh water can cause water column stratification. And what happens is when the water column would stratify with too much fresh water, the nutrients don't rise to the surface to nourish the phytoplankton. So that becomes a problem because phytoplankton are an important part of the Gulf. These rivers here, the St. John, up this way, Penobscot, Kennebec, and Merrimack discharge about 250 billion gallons into the Gulf annually. This is the Gulf Stream, and the Gulf Stream is coming here up the North Atlantic coast. It comes and starts heading east about Cape Hatteras, North Carolina, and then it continues across the Atlantic, and west of Ireland, it becomes the North Atlantic Current. In the process of traveling across the Atlantic, between evaporation and when the water starts getting into these cooling areas, between evaporation and sea ice that form, raise the water density by removing fresh water from the water stream and increasing the salt content. And up here, the heavier water sinks into the North Atlantic. And that's an important part of the AMOC, or the cycling of the currents through the Atlantic and throughout the rest of the world also. The Gulf Stream itself originates in the Gulf of Mexico, and it moves offshore, as I mentioned a little earlier, by Cape Hatteras, North Carolina. The Gulf Stream itself keeps these coastal waters here warm until you hit Cape Cod and George's Bank, which is right about here, which tend to deflect that warm water eastward, sending it towards Europe. Water on this northern edge of the Gulf Stream tends to mix with slope water, and slope water is just stratified water that sits on the continental shelf. This slope water will enter through the northeast channel, and as it enters, it is entering with a higher temperature and salinity than the Labrador current that's coming through. And these right here are warm core rings, eddies, spinning off from the Gulf Stream. The Gulf Stream itself originates in the in the Gulf of Mexico, and it flows through the Florida Straits down here. Over the past 40 years, the water flowing through these Florida Straits has slowed 4%. It's a small change, but is it natural variation or global heating? And because there's only 40 years worth of data, that remains to be seen which one it will be. And my thoughts are 2 or 3 decades from now, we'll have a better idea. The Gulf Stream does a lot of things for us and for Europe. It gives us a temperate climate. It also gives us, especially in the Gulf of Maine and along the East Coast, a lower sea level, because as the Gulf Stream current flows away from the coast, it tends to pull water away from the North American coast. The Gulf Stream is also responsible for bringing warm weather to parts of Europe that are considerably north of where we are. Changes in the Gulf Stream could change precipitation rates, rain and snow, cause stronger North Atlantic storms, and also have significant impact on the European climate. So here we are in the Gulf of Mexico with the Gulf Stream starting again, and it provides parts of Europe with warm winters and temperate summers. And this is about where we are right here in Maine, and this is Ireland and the British Isles. And if you look at this, you'll see that they are considerably north of where we are in terms of latitude. And this shows or illustrates that if we go through and look at Maine is located at about 45 degrees of latitude north. And that puts us in pretty much the same latitude as Milan, Italy, which is in the northern part of Italy. If you go up to Newfoundland, right about here, and you were to go across, Newfoundland, right about there, and you go across, it's going to be about the same latitude as Dublin Island. Newfoundland is considerably north of us. We have relatively cold weather. Newfoundland the same, but if you start looking at the British Isles, for them to get snow, it's more of a rarity than a common occurrence. Talk a bit about the bathymetry of the Gulf of Maine. The Gulf of Maine has deep basins and shallow banks. Okay, here's a few of the basins here: Wilkinson, Jordan, George's Basin, and one of the banks here would be George's Bank, the most famous, I believe, and Brown's Bank. These basins are glacially carved and generally about 180 to 600 feet deep. George's Basin is the deepest, and it's about 1,236 feet deep. In total, there are 21 basins within the Gulf of Maine, and 34% of the seafloor is comprised of basins. The basins themselves have deep and stratified water layers. There's little or no current, little or no sunlight, generally no sunlight, and the seafloor itself is fine-grained silt or mud. Finer grains tend to float out further into the sea. George's Bank, just right here, it's an elevated area of the seafloor. It's about 330 feet higher than any other area in the Gulf. And it separates the Gulf of Maine from the Atlantic Ocean. And take note here, it has an oval shape, and it's about 149 miles long by 75 miles wide. It's a very rich fishing area, or has been in the past. It lies on the continental shelf, 62 miles offshore. So here we are on the continental shelf with George's Bank, 62 miles away, you got land. It is larger than the area of the state of Massachusetts, and it is tidally mixed, mostly from those counterclockwise currents that go through there. On George's Bank, the average depth is 90 feet, and there's one area on the bank called George's Shoals, which is only 13 feet deep. One of the things that's so interesting about George's Bank and why it's so productive in terms of fisheries is that phytoplankton have 3 times faster growth in the George's Bank area. And that's because it's due to the mingling of the currents of the Labrador Current and the Gulf Stream. The other reason is that the water is shallow, and the shallow water allows the sunlight to penetrate, and phytoplankton needs sunlight in order to photosynthesize. George's Bank itself, right here in this picture, was formed by glacial sediment and outwash that sits on bedrock, because most of the bottom of the Gulf is really based on bedrock. About 12,000 years ago, George's Bank was attached to the mainland. There was a glacier on one side, an ocean on the other. It tended to have cooler summers and moderate winters. And in that time frame, the climate, the marine climate in the Gulf of Maine, or excuse me, on the coast of the Gulf at that time was very similar to what you might expect going off the southern coast of Greenland today. About 11,000 years ago, rising sea from the glaciers melting and rebound from the land as the weight of the glaciers was removed, the land side moving up again, formed George's Island. And 6,000 years ago, the island itself was submerged, and that formed George's Bank. From time to time, fishermen will find mammoth tusks, mammoth teeth, that type of prehistoric animal from the bank itself. And this is a walrus skull that is actually in the State of Maine Museum, and it was found on the coast of Maine about 4,000 years ago. So again, 4,000 years ago, we had a considerably colder climate than today. If I said that was found 4,000 years ago, I should say it's from 4,000 years ago. Benthic pumps. Okay? Benthic pumps occur around shoals, low areas, and undersea ledges. Okay, and they tend to be areas where there's a rich upwelling of nutrients from the deeper sea, and that attracts plankton, phytoplankton, and zooplankton. The plankton becomes concentrated as the water is forced by the currents through passageways and around the ledges. And the concentration of phytoplankton attracts filter feeding invertebrates. They come, they release eggs and larvae, and the fish follow. And an area that has these upwellings and these benthic pumps tends to have very good fishing. This is another picture of an upwelling, and it shows here that, you know, as the upwellings occur, as nutrient-rich water gets pushed up to the surface, and then you know, stays there and feeds phytoplankton. Phytoplankton are microscopic plants. Okay, zooplankton are microscopic animals. Over on the right here, phytoplankton. There are different types. The diatoms, cyanobacteria, and algae. Zooplankton, like this copepod over on the right, microscopic animals. And as I said, copepods are zooplankton, but it also includes krill. And there are 85 species of krill, and the largest krill itself is about 2 inches long. The thing about plankton is that plankton flows at the mercy of the currents. It does not have the ability to swim against the current or really move itself around. It's all dependent upon being moved by the currents. Plankton blooms. Plankton blooms. These lighter blue and lighter green and the milky blue areas are blooming phytoplankton. And this is a satellite photo that was taken on June 5th of 2022. This phytoplankton that's showing up is within 60 feet of the surface. And the blooms occur mainly in the spring and summer, and they tend to taper off in the fall. The blooms themselves can reduce sunlight. Obviously, they would block the sun from getting down, and cause problems with dissolved oxygen in the water. And that would happen when a bloom would die, and the plankton would sink to the bottom. And when it sinks to the bottom and starts to decompose, it would end up using the oxygen that's available. And bottom-dwelling creatures such as lobsters, that type of thing, can have a lot of problems because they will not have enough dissolved oxygen in the water for them to survive. The coast itself, and this is pretty much throughout the whole Gulf of Maine, even though this is a shot of the Maine coast. The coast is irregular due to the glacially carved bedrock on the land that continues as the sea floor. The seabed itself, and if you look at this color coding, this brownish is mud, the gray is rock, orange is gravel, and the yellow is sand. The seabed itself sits on the intercontinental shelf. 4/5 of the seabed is comprised of bedrock and muddy basins. Rocky bottoms are dominant, less than 164 feet, and muddy bottoms are dominant, greater than 164 feet. Gravel and sandy seabeds occur generally at depths between 30 and 100 feet deep. And there are relatively few sandy seafloor areas in the Gulf itself. And if you look at over here at the bottom, over at the bottom right, it shows the percentage of each type of substrate. Rock at 41%, mud at 39%, gravel at 12%, and sand itself at 8%. This is a picture of the bathymetry of the Gulf, and you can see it's pretty much off Portsmouth. And this is, I would like you to pay attention to this particular section right here that's squared off. Okay, this is actually what the this is actually what the sediment looks like in that area. One of the things about this sediment, it tends to build an homogeneous seabed. The grain size itself, whether gravel, sand, the actual size of the sand grains determines the biota of what lives there, whether it's plant or animal. Seabed knowledge is important for fisheries management and also for human seafloor activity. Some of the things in terms of fishing management, what types of floors there seabed will attract different types of fish. Also, if you're trawling, you want to know what is down below. If we have infrastructure like cables and pipelines that need to be put in, and they do go in under the ocean, and sometimes in areas that seem quite protected. But the fact is that when they go in, if you have adequate seafloor mapping, you can put them in with the least amount of disruption to the sediment and to the creatures down there. As of 2002, about 15% of the Gulf of Maine was mapped with sufficient detail. And I will say that since then, I haven't really seen a lot more mapping taking place. There was an effort to get the mapping done around the year 2000. But one of the things that's noteworthy about this, in the south and southwestern parts of the Gulf, more towards our direction, we tend to have thick sediment and glacial deposits. But if you go to the north and eastern parts of the Gulf of Maine, there tends to be a very rocky bottom with irregular ridges, pinnacles, and channels down there. There are various mapping techniques that are used to map ocean bottoms, and I'm not going to go through all of them, but the idea is that these techniques will be used, and oftentimes the results will be overlaid one over the other to give the real picture of what's down below. Once this mapping has been done, a process called ground truth takes place, and that's when geological and biological samples are collected from the ocean bottom to verify that what the instruments told them was there was actually what is there. And while that's going on, photo and video documentation of the bottom also takes place. And this is an example. This slide here is an example. This is a different, one particular type of mapping technique here. And this is where they took an overlay from another technique and put it on top of the first. And what it does is it highlights, like red and orange, you have coarse sand or rock. If it's green, you have sand or muddy sand. If it's blue, it means that it's mud or sandy mud. Not sure what the difference between muddy sand and sandy mud is, but I'm thinking it's the predominance of mud or sand in that area. And this is an example of how this bottom is helpful. In fact, it's the same. It's from the same picture as before. Oh, excuse me, same area as before. This is the Stellwagen. This blue line here is the Stellwagen Bank Natural Marine Sanctuary. Okay, a protected area, and what they have here is this red dotted line, and that is a fiber optic cable that needed to be run pretty much through the sanctuary. And what they did here, as you can see, is they routed this across soft sediment, which made it easier to put in, and it caused less disruption to other parts of the seabed. And what they're able to do, because of their mapping and the proving out that it was there, in order to put this project in or get the cable in, there was less bottom sampling that they had to do, and there was far less sediment disruption. And creatures live in the sediment, so you don't want to see it disturbed. Another example of how knowing what's on the bottom is very helpful is with this sketch from the, well, actually for this view from the Browns Bank scallop fishery. If you look at this, this map here, you'll see that the orange is prime scallop habitat, and the blue is the fishing boat path, okay? Notice this. This is the first shot when they're going through and they're fishing for scallops, and you'll notice that they are the predominant area that they're dragging for these scallops is outside of where the scallops are predominantly located. Over on this right-hand side, you'll see that when they did the drag, they dragged it throughout the area where the scallops lived. And when I go through these next figures, keep in mind that the scallop harvest is controlled by quota. So they can only take so many scallop out of there, okay? When this prime scallop habitat is identified, they found that the trawl time per metric ton was reduced from 6.4 to 2.4 hours. So you're seeing about a two-thirds reduction in the amount of time that fishermen have to be out at sea hauling the dragger. The area dragged, which is this area in blue right here, anything in blue, is reduced by 75%. Fuel consumption on the fishing boat was also reduced as much as 36%, okay? The thing about this too is that there's less bycatch of unwanted species, or less bycatch of species that aren't the target species, and far less seabed disturbance. And if you look at a video of dragging for scallops, a dragger is basically a large net that's sunk down to to whatever depth they're going after. In this case, goes down to the seabed. And at the leading part of that net that's pulled along by the boat, there are spikes, at least a foot long, and those spikes are pulled through the sediment, and you'll see that the scallops themselves come flipping out of the sediment and go into the net. Okay. So you map the seafloor. You have improved fisheries management. Okay, and efficiency. You minimize seafloor disruption by gear, and you also reduce bycatch and gear loss. And this is important when you think about this. In the Bay of Fundy, northern part of the Gulf of Maine, since 2007, there's been a significant decline in horse mussels. Horse mussels are a large mussel, and they form an important part of the benthic community, and significant decline, and that has happened in scallop fishing areas. The mussel beds got impacted, probably destroyed. This is getting towards the winding up. This is the shore of Wells, Kennebunk. And we'll end with actually one more after this. This is cod, probably the most important fisheries that we had in the Gulf, and what drew Europeans to the Gulf and Grand Banks originally. And ending up here with some deep sea coral from the Gulf of Maine. So that would be it. So I'm open for any questions or observations, whatever.
Thanks so much, Steve. Wonderful. We had a question very early on when you were showing the basalt dike. Question was, is basalt stone softer than granite?
I would say definitely it is. Granite is a very hard stone, and you can see by that wear that the basalt is softer, but it's still a very hard rock.
If anyone else has questions, you can type them in the chat or unmute yourself and ask. We have about maybe 5 minutes for questions.
I don't have a question. I took a lot of notes of things that I'll look up because I don't want to take your time, but I do want to thank you. It was really interesting.
Well, thank you. Appreciate the comment. I will say this about the Gulf of Maine, as the more I've studied it, there's always some new thing to find that's interesting about it. Kind of doesn't end.
Great presentation, Steve. Lots of terms to look up and lots of more research to do. So thanks for the recording. Much appreciated.
Okay, all right, Gary.
Yes, and this recording will go up on the Wells Reserves YouTube site. It might take a little while. One of my colleagues is responsible for that, and it depends on his availability, but you can keep your eyes out for that.
Okay.
Steve, a question about climate change and the currents changing, which I've heard about in the past. How worried are you about the changes happening in the Gulf of Maine and Georgia's banks for both fishing and also the fish and mammals who live there?
Well, if there are, if you look at like climate change scenarios, there are scenarios that are disastrous, others not so much. I try to look at it somewhat optimistically, though it can be difficult when you read the headlines. As far as the fisheries of the Gulf of Maine, Georgia's bank, the Grand Banks, they were the rich. I can't say they were the richest, but they were definitely one of the richest fisheries ever. And today, people go to Georgia's bank, not the Grand Banks. Skippers will report catching dogfish. When Henry Cabot came and discovered it, 1497, he made a note that they were catching codfish in barrels, not barrels, in baskets. And I interpreted that as they would stick a net in and they were able to scoop them up. So they were catching, codfish, very important food source for the Europeans. Today, you don't have many cod out there. And like I said, the guys out there catching dogfish, not quite the high value product that a cod would be. But I hear they're good for fish sticks. But I don't eat fish sticks as a rule.
Steve, I see we're at 1 o'clock, but there is one more question in the chat. The question was, where is the coral located? So I think referring to your last slide there.
The coral is located in very deep areas. As far as an actual physical location, you'd have to look at the map, but it's the deep water corals and they live in cold water. And interestingly enough, as colorful as they are, they grow in a dark area. So the only way you can enjoy the color is when somebody goes down and takes a picture of them in color.
Thank you, Steve, and thank you all for joining today. That was so informative.